Good morning, everyone. I decided that I should create a small video of taking up certain questions from 8 and 9, exercise 1.2, the factorial questions. So I'm going to take up the ones that are most asked of me on a yearly basis. The first one that I'm going to take up is 8b. So we're going to kind of start a little bit easier. And it is n factorial times n plus 1. So right away when I look at this, the order in which this question is written is wrong. The factorial should always be the last item in the expression. So notice the n plus 1 is sort of like the doorman. We saw a couple of those, quite a few of them in our examples from yesterday. Then n factorial. So I'm now going to expand that n factorial using my factorial law, which is n minus 1, n minus 2, n minus 3. Now because everything's in brackets, I'm going to put the n in brackets as well. Dot, 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 3 times 2 times 1. So n plus 1 was the doorman. N factorial expanded looks exactly like this. And now I'm going to take a look at the question and attempt to simplify it. When I take a look at the question, look at what I see. Nice, beautiful consecutive numbers decreasing by 1. So the simplified answer is n plus 1 factorial. Beautiful. 8c. Let's take a look at it. N minus 1 bracket, n minus 1 factorial bracket n squared plus n. Now, using our logic from the previous question, 8b, the order in which this question is written is incorrect. So let's switch it. Just flip-flop the order. Now, we had an example like this from yesterday in which my doorman term, my coefficient, needs to be factored. And I'm going to use common factoring out an n. Okay. I'm now going to use my factorial law, which says n minus 1, n minus 2, n minus 3, dot, 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 3, 2, 1. Now remember, I'm kind of skipping a step here. Okay, I'm kind of skipping a step, and I'm allowed to skip that step because I know that the numbers are going to drop by 1. I sort of proved that to myself in all my examples. Okay, let's take a look. 0, 1, negative 1, negative 2, negative 3, negative 4, and so on. It's not in the right order. It's not in the right order. The numbers need to be decreasing by 1. What if I wrote it like this? Let me take a look at that. 1, 0, minus 1, minus 2, minus 3, minus 4. Way better. The numbers are decreasing by 1. So my simplified answer is going to be n plus 1 factorial. Beautiful. 8d. Let's take a look at it. Again, we see a question given to us that's in the wrong order. The setup is incorrect. So let's switch. Let's put the coefficient doorman out in front. And again, we did an example like this from our notes in which this has to be factored. It's an easy trinomial, and we ask ourselves what two numbers multiply by 2, or multiply to 2, and add to 3. Positive 2 and positive 1. Beautiful. I'm going to use my factorial law. N minus 1, n minus 2, n minus 3. Because everything in brackets, I'm going to put n in brackets, dot, 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 3 times 2 times 1. Again, take a look at these numbers. They're not in the appropriate order. They're not in the appropriate order. This is going up by 1. That's not the way these work. N plus 2, n plus 1, n minus 1, n minus 2, n minus 3, dot, 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 3 times 2 times 1. 2, 1, 0, negative 1, negative 2, negative 3, simplified into n plus 2 factorial. So I hope that helps with question 8. I hope that helps a lot with question 8. What I'd like to look at now is 9C and D. Please and thanks. Let me give a second there just in case people need to take a quick look at that again. Okay, give me a moment. 9C is 3 times n plus 1 factorial all over n minus 1 factorial equal to 126. Again, notice the difference in the instructions between 8 and 9. 8 asks for you to simplify, clean up. 9 asks for you to solve. Okay, let's go through it slowly. I'm going to put a big equals and the 126. Big division line, don't want to cramp my work. The 3 is like the doorman. I'm going to leave him out in front, and I'm going to deal with the factorial. N minus 1, n minus 2, n minus 3, dot, 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 3, 2, 1. Notice 1, 0, negative 1, negative 2. Decreasing by natural consecutive numbers. Here we go again. N on the bottom. N minus 1. N minus 2. N minus 3. Dot, 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 3, 2, 1. Now some of you are probably asking, Ms. Martel, when I see the repetitive pattern starting back here, am I really required to write all these iterations? Absolutely not, guys. You can write the n minus 1, the dot, 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 3, 2, 1, and you're totally good. If you're getting good at this and you're seeing that the repetitive pattern starts at the n minus 1, you can save yourself some of that legwork. So I'm going to cancel everything from the n minus 1 on, and that leaves me with this. Kind of ugly, truth be told, the way I have it written. Because when I have things written in an algebraic expression, I prefer the monomials to be written first and then the binomial. Okay, so 3n times n plus 1, and then I'm going to rainbow that in. 3n squared, 3n times n, plus 3n equals 126. I'm going to bring everything over to one side. And I'm kind of getting nervous because I'm looking at this thing thinking, geez, am I going to have to do a tricky trinomial? You may have to do a tricky trinomial. But when I'm seeing 126, I'm seeing 3, 3, and 126, I'm going to do a little check on my calculator to see whether 126 divides by 3. Yes, it does. So watch what I'm going to do next. I'm going to divide every one of my terms by 3. So 3n squared divided by 3, 3n divided by 3, negative 126 divided by 3, 0 divided by 3. I'm happier now because I have a beautiful, easy trinomial where I'm going to ask myself what two numbers multiply to 42 and add or subtract to 1. Factored. I'm now going to take each of those factors and equate them to 0 and solve. Now, we talked about this yesterday too. We said, does this really mean that there are two answers? I don't know. I've got to go and check. So if I put 6 in for n up at the top, I'll get 7 factorial. I can solve that, 6 plus 1. If I put 6 in the bottom, I'll get 5 factorial, 6 minus 1. So that seems okay. Now what about this? Negative 7 plus 1. That gives me negative 6. Not allowed to have a negative factorial. Inadmissible. Answer for a factorial question is n equal to 6. Beautifully done. Okay, let's take a look at 9D. 9D is probably the hardest one. Oops. Kind of interesting. Never seen that in any of my examples, but that's okay. Let's deal with it. So again, big equal sign, 84n. The 2 is going to be like the doorman, and I'm going to deal with n factorial. N factorial is our classic rule of n minus 1, n minus 2, n minus 3, dot, 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 3 times 2 times 1. Looking at the denominator, n minus 1, n minus 2. I don't think I'm going to take it further because I can see the repetitive pattern. I'm hoping all of you are seeing it as well. You're seeing that repetitive pattern. Start at n minus 3. Big scribble, big scribble. So what am I left with? Now, remember in our very, very, very last example yesterday, I said to you, if I look at this n, and I look at this n, and I look at this n, and I multiplied them, that would make a cubic. We don't want you to expand anything larger than a quadratic, anything larger than a squared. So do not expand anything larger than a squared. So if I'm not going to expand anything larger than a squared, I better take a look at the question, put my eyes on the equal sign, look at the left and look at the right, and see if I see anything that's matchy-matchy. See if I see anything that I could cancel. I certainly do. So what am I left with? Anybody else got any other ideas before we start expanding? I got an idea. What if I divide both sides by 2? So if I divided this side by 2, I'd be left with this. And if I divide 84 divided by 2, I'm left with 42. Notice how I got rid of the ends. I divided this side by 2, got rid of it, divided this side by 2. And now when I'm ready to expand, things look a lot nicer and neater. So let's try it. I'm going to FOIL. First times first. Outside times outside. Inside times inside. Last times last. I'm going to bring everything over to the left-hand side. I'm going to collect my like terms. So negative 2n minus 1n, positive 2 minus 42. And now I'm going to ask myself, can I factor this thing? Again, easy trinomial. What multiplies to negative 40 and adds or subtracts to negative 3, negative 8, and positive 5? Take each of those entities and solve them by setting the binomial equal to 0 and isolating the variable. And then I've got to decide, are both of these answers legitimate? In order to decide that, I've got to look back in the question. Can I substitute 8 in here? Can I substitute 8 in here? Yes, I can in both cases. Can I substitute negative 5 in here? No, I cannot. And the reason I can't is because I'm not allowed to have a negative factorial. Hope this helps with the homework. We'll be moving on to a new lesson on Thursday. Thank you.